Hi, everyone, and welcome back to Organic Chemistry on YouTube. Today, we're going to be talking about the Markovnikov rule and how it relates to adding electrophiles across alkenes. Building on the last episode, this involves the alkene acting like a nucleophile and attacking an electrophile. A Markovnikov product is just a preference for adding to the substituted end of an alkene instead of the unsubstituted or less substituted end of an alkene. And there can also be anti-Markovnikov products. So let's show some examples. Suppose you had the addition of acid, H3O plus, and water to this alkene shown here. The two products that you can get from this reaction are these two. We can have the alcohol add to the less substituted side of the alkene, or you could have the alcohol add to the more substituted end of the alkene. And just so we're totally clear, when I say the more substituted end of the alkene, I'm talking about the green terminus here, which I'm showing this green dot, and the less substituted side is the blue dot. Okay, so let's work out this mechanism. So I'm going to first draw the reaction mechanism to the product A, which is the anti-Markovnikov product. So the first step, just like the last episode, these electrons attack the acidic hydrogen. It breaks the hydrogen-oxygen bond, and it forms this intermediate. Noticing the secondary carbocation, the water that results from the deprotonation of H3O can then attack this cation, and a second water molecule can come in, deprotonate, and lead to the product A. If that was fast, feel free to pause the video and rewatch this. Alternatively, these two electrons can also attack the hydrogen of the H3O plus and add the hydrogen to the opposite side of the molecule, that is to the blue carbon, which is the less substituted end. Now here you create a tertiary carbocation, and water again can attack this carbocation here, form this intermediate, which is a very acidic protonated alcohol, deprotonate that hydrogen, and then result in the product B. Now the reason that B, the Markovnikov product, is favored is because of the difference in energy. So the reason that the Markovnikov product is favored is because the Markovnikov product B involves a tertiary carbocation as a reactive intermediate, while the anti-Markovnikov product involves a secondary carbocation, which is less stable than a tertiary carbocation. So finally, questions you might want to ask in office hour. One, can reactions be designed to override Markovnikov preference for the addition reaction? What are such strategies? And does the selectivity always depend on the stability of the reactive intermediate? So with that, that's been Organic Chemistry in 5 minutes or less. Thanks for tuning in.